All right, so continuing on where we left off, let's take a look at number 6, and I'm going to approach this problem graphically, okay? All right, so over here, we're asked to find the limit as x approaches 1 from the right, the limit as x approaches 1 from the left, and the limit as x approaches 1 overall of the function. Okay, so remember, this is your right-hand limit and your left-hand limit. And so you have a piecewise function, right? So basically, this is saying, the graph of, your parabola for x does not equal to 1, right? Which means there's going to be a hole at x is equal to 1 when you graph this. But then this guy right here, right, f of x is equal to 2 when x is equal to 1, right? This just means that f of 1 is equal to 2, okay? All right, so let's graph it, and then we can evaluate what the limits are. So if I were to just do a quick sketch, right, I know this is my parabola, 1 minus x squared. Draw some tick marks over here. Okay, so this is a parabola shifted, parabola that's going upside down, shifted 1 unit to the top. Right, 1 minus x squared is same thing as negative x squared plus 1, right? This is my function. And it's going to go down, right? So a quick sketch, if you go down 1 over 1, right, your parabola is going to look something like this. There's your negative x squared plus 1, okay? All right, now, remember, for our piecewise function, right, remember there's a hole here. So there's actually a hole at x is equal to 1, right? So if it does not exist, why don't you erase this and make it into a hole, right? So what I've graphed so far is 1 minus x squared for x does not equal to 1. So that's how you would graph it, right? And then this bottom part of the piecewise, right? X is equal to 1, f of x is equal to 2, right? F of 1 is equal to 2. Well, at 1 it's equal to 2. Okay, so there's a rough sketch of my graph. And now let's answer the question. The limit as x approaches 1 from the right of f of x, well, as x approaches 1 from the right, x is approaching 1 from the right, the y value looks like it's getting close to 0. What's the limit as x approaches 1 from the left? Okay, so x is approaching 1 from the left, right? The y value is also getting close to 0. And so what's the limit overall? The limit as x approaches 1 of f of x, right? This is my left-hand side. This is my right-hand limit. They both have to equal the same number. And if they both equal the same number, well, that's just the limit overall. Okay? So this would be the solution to your limit problem on number 6. I don't care what's happening at this, at 1, right? At 1, the value is 2. But the limit as x approaches 1 from the left, right, is 0. X approaches 1 from the right is also 0. And the overall limit would be 0, right? This is your left-hand limit, LHL, and this is your right-hand limit. If they both equal, then the limit overall is just whatever that number is, okay? All right, so moving on to number 7. Before I do this problem, I must talk about direct substitution. And so if you have a limit, right, that, x approaches some number of some type of function, a lot of functions you can just solve by directly substituting wherever this number is into the function. So the limit overall is just f of c. And this works well for, polynomial functions, rational, square root, linear. I think your textbook calls it well-behaved functions. Okay, so I'm going to go in detail about which functions can you just solve by using direct substitution, and which functions that you actually really need to manipulate later on in a future video. Okay, but for this one right here, right, it's like I don't really want to go through the process of graphing it, and I have some kind of square root function, right? All I need to do, right, is take this number right here and plug it in. So let me write this problem out again. Limit as x approaches negative 0.5. should be negative 0.5. Of x plus 2, square root of x plus 2 over x plus 1. All I need to do is plug it in. Okay, so negative 0.5 plus 2, negative 0.5 plus 1. And over here, I'm going to get 1.5, which is 3 over 2. And over here, I'm going to get 1/2. If I multiply top and bottom by 2, right, because it's a complex fraction, I'm just going to get the square root of 3. Okay, so the limit as x approaches negative 0.5 of square root of x plus 2 over x plus 1 is just the square root of 3. Okay, so a lot of functions you can just solve by direct finding the limits using direct substitution. And as I mentioned, the more of your less complicated functions, you can do that. Like for piecewise, as you'll see in this next example, you might have to graph it or you might have to simplify it first. Okay. All right. So speaking of piecewise, let's take a look at this last problem here. So what makes this problem tricky is there's both an absolute value and a square root. And so we're going to go back to using the example I did on case number 1 in the previous notes. Using the definition of absolute value, I'm going to split this up as a piecewise. Okay, so again, if you are forgetting the definition of piecewise, go look back at my last video. I'm going to rewrite this as a piecewise function. And so before I even answer these questions right here, let's see if I could simplify this. Okay, all right, so I need to split it up by writing it like this. This is the square root of 2x over x minus 1, and I drop the absolute value symbol, x minus 1, comma, to get the domain right, I set the argument, whatever's inside the argument of my absolute value symbol, and I set it greater than or equal to 0. Okay, so this comes from the definition of absolute value. And then I do the same thing for the bottom part. This is the square root of 2x, x minus 1. I drop the absolute value symbol again, but this time I put a negative here, okay? Because again, this is the definition of absolute value. And I set the argument, this time, less than 0. Okay, so that's how you want to start off initially, right? And so I guess you could do it on the next line. When you cancel this out, right? This and this are going to cancel out, right? That means there's going to be a hole at x is equal to 1, right? Well, if there's a hole at x is equal to 1, if you solve for x on this domain right here, right, this will be x is greater than or equal to 1. You need to change it to x is greater than 1. Okay, this is changed since hole at x is equal to 1, right? So no longer do I have the equal sign here. It's because there's a hole at 1, okay? Because I ask you, what's f of 1? You would say it's undefined, right? Because you can't plug in 1 over here. It's going to make your denominator 0. Okay, so this cancels out. And then on the bottom part, right, this is going to cancel out. You're just going to get the square of negative 2x for x is less than 1. Okay, so this is the piecewise function that you want to analyze as, you know, you simplify this really complicated function. And this looks a little bit less intimidating than this, right? Okay, now that we have our piecewise, we can answer the question. The limit as x approaches 1 from the right. Well, I don't need a graph this time. I don't really care about what the square root of 2x is because I can evaluate what the limit of x approaches 1 from the right is using direct substitution. Now, from the right, right, to the right of 1 would be this top function. Okay, and again, using direct substitution, right, if you plug in 1, you're just going to get the square root of 2. Okay, so the limit as x approaches 1 from the right is the square root of 2. The limit as x approaches 1 from the left. Well, I don't know what this graphic entirely looks like, but to the left of 1, I already have the domains defined by x is less than 1. And again, just plugging in, using direct substitution, okay, this means to the left, from the left, don't plug in negative 1, is the square root of 2 times 1, right? But there's a negative here, so this is the square root of negative 2. I plug it into the bottom function. What do I plug in? I plug in positive 1, right? Because this is from the left of 1. And now if I ask you what is the limit overall as x approaches 1, remember for a limit to exist, right, the right-hand limit and the left-hand limit have to be the same number, right? You would just say does not exist. These are not the same number, and you would say the limit does not exist. And that's pretty much it for limits in 11.1. Primarily, you're going to be doing problems using a table and also just looking at the graph. And then you'll have some simple direct substitution problems, such as problem number 7 over here. But then the real tricky ones are these piecewise ones that you're going to have to kind of simplify. And also some of these piecewise that you might have to graph and make sure you understand left-hand limit and right-hand limit, which doesn't really get introduced until section 11.2, but I figure it's kind of important to give you like a little preview.